Alrighty, so 12.3, measures of central tendency. I think you'll like this one. You have done it before. Mean, median, mode, range, stuff like that. So here we go again. Measure of central tendency. Definition is calculation that describes a collection of data. Again, examples are mean, median, and mode. One of my favorite terms here is outlier. A data value that is much greater or less than the other values in a data set. So if I gave you some bowling scores here, right, and I listed them out, this one sticks out way beyond. If I listed them smallest to biggest, you'd see that. So if this was my bowling scores, which I only wish it was, normally you score a lot less. This 189, though, you had a real good day. Maybe you drank a bunch of extra coffee that day, I don't know. But it's an outlier. A mean, when someone says the word average, like your average score, this is what they really mean. mean. All right. The sum of a set of numbers divided by the number of items in a set. Again, often called the average. Most commonly used measure of central tendency. Uses all available information. Should not be used if an outlier is present. So if one, that kind of sets the whole thing off and kind of gives us a false sense of what the actual mean or the average is. Okay, so mean, that's the first one. It's finding the average. Add all these up. By the way, when you do that, you're going to get 976. There we go. You're going to get 976. You divide that by the number of numbers. So 1, 2, 3, 4, 5, 6, 7, 8. Make sure you did it right. 1, 2, 3, 4, 5, 6, 7, 8. So 976 divided by 8 is 122. Oops, hang on. Divided by 8 is 122. That's the mean. Median, this is another measure of central tendency. The number in the middle of a set of data that is listed from smallest to biggest, or the mean of the middle numbers. So if there's two middle numbers, right, you just take the average of those two. So add them out, divide by 2. Easy to compute for small sets of numbers. Use when there is an outlier, because it kind of mitigates that whole, bigger than the rest or smaller than the rest number thing. Tends to vary from sample to sample from the same population, where mean is more stable and a better representation in large populations. A median works better in smaller populations. Alrighty, so you see here I've listed them in order smallest to biggest, and if it occurs more than once, you write it that many times. And so the median is the middle number, so there's 8, 1, 2, 3, 4. Well, there's no actual middle number here, right? So I have to take the average of 109 and 113. So again, in order to do that, we add those two middle ones up, 109 plus 113, and get 222. Divide by 2, and I get 111 for my median. The mode is the most frequently occurring number, so the number of numbers that occur most often. There can be more than one of these, by the way, if they tie. Least used, useless for small sets of data, requires no calculation, and can be used for qualitative data as well as quantitative. Again, qualitative, talking about how many, like hair color, right? That's not actually a number, or eye color, or types of food eaten, right? Taco is not a number, but it's a qualitative data. Quantitative is numbers. So the mode here, we can obviously see the number that occurs the most often is that 104 occurs 3 times. Look at that, no calculation, boom, done. So most often when I bowl, I get a 104, it looks like. Range is the measure of dispersion. Describes how spread out the values of data are. The most common, again, is range. Range is a set of data, the difference between the smallest and the biggest. So in the last example, it'd be 189 minus 104, which is 85. And this is where the range gets bigger because of that outlier. If I threw it out, I'd have a much smaller range. So you see that my bowling scores, are, which I wish they were, clustered around a smaller set of data.